Good morning, everyone. My name is Hasna Fauziyah, and I will explain a paper about water resources modeling using system dynamic in Vensim, a case study risk analysis of Sevidrat Dam reservoir intake decrease on downstream agricultural water demand. The first slide is about research problems. This paper discusses a critical issue in water resource management, the impact of reduced water supply from Sevidrat Dam on downstream agricultural water demand. The core problem being addressed is the dynamic interactions between water availability and agricultural sector, particularly when there is a decrease in water storage and flow due to environmental or policy change. The dynamic nature of this problem, which involves multiple feedback loops and time-dependent variables, makes it difficult to predict outcomes using traditional methods. The paper problem's scope is focused on understanding how different water supply scenarios can affect agricultural water demand and what measures can be taken to manage the risk of water shortage. And what is the solutions to this paper? To address the problem, this paper using system dynamics techniques. System dynamics is an effective methodology for studying complex interconnected systems with feedback loop delays nonlinear behavior. Using SD, the researchers are able to simulate various scenarios of water distribution and demand, considering factors such as water inflow of the dam, storage levels in the dam, agricultural demand, potential environmental or policy change that might influence water availability. The solution provided by research is to model the entire water distribution system in a Vensim software. Using the model, the study can assess potential consequences of various water management policies and help identify the best strategies for mitigating the risk. And let's continue into the research objective. The primary objective of the research is to create a dynamic model of water resource management that can simulate the effect of change in water availability on downstream agricultural demand. The study aims to demonstrate the following. 1 is predictions of future scenarios. 2 is risk assessment. 3 is policy guidance. This is the modeling step. The Sevidrat Dam operation modeling and river flow along its path is presented in this figure 1, using cause and effect and flow and deficit charts. The final model consists of the following primary components. Prepare the input variable file for the software, define the required irrigation water assigned into the dam, define the outflow of the reservoir, water flow extraction and return along the river path, Sevidrat Dam water requirements fulfillment reliability assessment. And let's continue into the next page, which is about modeling and results. In this figure 2, we examine the effect of an inflow decrease of 15%, 30%, and 45% on the water requirements fulfillment. And let's see into the figure 3. This is the reliability of agri-demand, the effects of inflow decrease to the Sevidrat Dam and reservoir on water requirement fulfillment. And let's go into the conclusions. In this study, the operations of Sevidrat Dam was modeled using dynamic system study. Reliable modeling requires a precise assessment of Sevidrat watershed, including the mid-basin river characteristics, irrigation system requirements, etc. After validation and calibration of the model, the effects of different factors of water requirements fulfillment reliability were evaluated. 3 scenarios in which the water inflow of the reservoir is decreased have been used as a modeling assumption, which show a significant decrease in water requirements reliability, which is counterproductive to the basic goal for the Sevidrat Dam constructions. And this is the references. Thank you very much.